Hey folks, in this video we're going to take a look at how do we use pthreads to take the sum of different parts of an array. The main reason why we're looking at this problem is because we want to see how to tell threads to do different work that maybe can potentially be combined later on in your program. Now, even though that's our goal, it's going to take a little bit of work to get there, right? So we're going to see a few different things. Somehow the advantage here is we're going to look a little bit more at why you'd actually want to, well, we're going to look at a problem that basically is why you'd want to use threads. Instead of being something that is very, demo-ish, right? Obviously, there's not a whole lot of point to displaying something in a multi-threaded environment, right? Really, when you get to a computational task, that's maybe more when threads make sense. So let's suppose we have an array. So I have an array of a certain size. I'm just going to assume for a second that's a size 6. I think that's size 6. That is size 6. And we're going to have these different indices, okay? So my problem, right, is that I want to basically try to sum different parts of it. Let's just write in some dummy values here. So I'm going to put in these. I've already picked these out. Technically, I picked these out years ago, I suppose. So 334, 222, right? So my whole problem here is going to be, how can I make one thread add up this while I make another one add up that, right? That's going to be my goal, right? So I'm going to have my T1 maybe process that, and my T2 process that, right? Because somehow what's happening is I'm doing computational work in parallel, right? So this is something that's a little bit more serious, just adding, but it is basically work, right? And the goal is it'll happen at the same time. And you can maybe imagine that if I had an array of, a million entries, this would be a speed up, right? So we're going to try doing this approach here. And it's going to be a little bit tricky because basically both threads need to know where to start and where to end, right? So let me maybe start making some annotations here, right? I kind of get the sense that this whole array here, right, this is going to be somehow my data. And this data, right, this is going to be owned by my main process. So I'll just put P1 over here, right? So P1, right, knows about this data, right, has this data. And what's going to happen is that my threads here, right, will maybe have a additional reference themselves to this data, right? So both of them can see it, right? That's how it we might want it to look, or might want it to work. And so we have these kind of two different threads that are running. Each one's going to need to know, where do I start? Where do I end, right? Where do I start? Where do I end, right? Those are the questions. And so I need to tell them kind of different pieces of data, which is actually a little bit more tricky than what we've done before. Before we've done something like giving it like, one pointer to like, okay, work on this element. But now we're saying we want to give it a start and an end, right? That's a little bit different. And what we also really want to think about is, maybe there's a result, right? So maybe there's a result that we get from that one. There's a result that we get from that one, right? So there's kind of some different pieces of data that each thread's going to need to know about in order to do its job, okay? But this is going to be kind of my goal, right? Is that T1 runs, it can see the data array, it loops over indices 0, 1, and 2, sums them up, and then returns the result, right? T2, right, gets access to that data array, right, that global data. It sums up indices 3, 4, and 5, and then returns the result, right? So that's going to be my basic pattern here that I want, right? Maybe remembering back to the previous video, this isn't exactly going to be optimal yet because they're both acting on the same piece of global data, and so that means it'll kind of have to be shared between them. But it's a good step in that direction, right? It's a good step because now we actually are doing work, right? Doing work over an interval, right? So that's where the direction we want to go in. Okay, so let's go back to our code. So I've already cleaned it up a little bit since the last video, just so we have an easier time working with it. So let's see. The first thing I'm going to do, and maybe I'll bring back the drawing for a second. The first thing I think I'm going to do is basically figure out how to do this stuff here, right? So every thread needs to be told different pieces of information. Okay, I need that for sure. So how can I possibly do that? How can I give it different pieces of information? I know that I will get basically one parameter in the thread create, where is it over here? One parameter to give it data, right? So how do I get 4 pieces in there? This seems like a problem at first, but it's actually straightforward. It's straightforward because what we can do is pass it a struct, right? We can pass it a struct of data. And that struct can contain different parts, okay? So let's start by doing that. I'm going to create a new struct over here, and I'm going to call it, not that, call this, I'm going to call it thread info. And so what this is going to be is like a blob or a chunk of information that I give to each thread so it knows what to do. Okay. So coming from my diagram, I'm going to have to basically give it a start of that array where I want it to work, an end in that array. I need those for sure. I also want to access the data. What I should probably do, because the data belongs to the parent process, is save a pointer to it. And so I'm going to do it in star here, in star data, right? So I'm going to have, as a thread, a pointer to the data that the main program has already allocated somewhere, right? So I'll do something like that. Next, what I can do, right, is I can say, okay, I have, what to work with. How do I get my result? I'm going to add something else here called the result variable, right? So I'm going to have this, right? So basically, this tells me where to work. This tells me what I'm working on, and this is where I'll put my result. That way, the main program can get it back, right? Because I want to get information out of the thread as well. I could, I suppose, return it out of the thread join, but I want to put it in the struct just so we can kind of see the full potential power here of doing it this way. So there's a little package of information that we're going to give to each of the threads. Okay, so let's see what we can do here. I'm trying to decide where to start here. The problem is very much a chicken and egg thing. Maybe we'll try doing the runner function first, right? It'll be a little hard to visualize. We'll try the runner function first. So I get the runner function, right? So I have the runner function, right? I'm going to just call it something simple like compute partial sum, something like that, right? And it's got to, again, be void star. Always the void star, right? Because it doesn't know what type I want to give it. So like this. There is, of course, a bit of boilerplate. We know that we have a pthread exit 0 at the end. Got to have that for sure. And then also what we have, right, is the conversion, right? We have the type conversion. So in the past, right, we did that where we had to basically go and cast it, right, from the void to what it actually is, right? So we're going to do that as well here. So I'm going to create basically a struct pointer, struct thread info pointer variable. We'll just call that, I don't know, info. And then we'll basically assign that over to data, right? So I'll do that little cast there, set that to data. All right, so now I have kind of that information available in my thread, right? So you can imagine for a second, we're basically going to get these different pieces of information in, right? And these different pieces of information, right, they'll look something like this, right? So for thread 1, right, so going over here, right, this will basically look like start at 0. Start at 0. I'm actually going to give it an end of 3 because then I can do a less than, or I can do like less than n, right? So if I give it 1 greater than, it'll basically mean that I go up till 2, right, if I have a loop at a certain point. So I'm going to go basically 0 and then 3, right, for my start and then end parameters. For data, I will of course have this pointer to the memory that the main program allocated. Okay, last thing there is int result. So that really is not going to have anything in there, right? That's going to be kind of a question mark, right? So that's a question mark. This is sort of an arrow over here, right? So these are the 4 pieces of data, right, that I'll be getting in my thread info struct. Okay, so I have those coming in. So let's see. I want to start by basically taking the sum, right? So I want to take the sum. Once I have it, then I can store it, right? So let me just grab a quick variable here that I can store my work in progress sum into. So I'll do that. Now I'm going to have a loop, right? And so my loop here, the goal is let me move along just this subpart of the array, right? The part that's bounded by 0 and 3, right? I want to move along that. So I'm going to go the following. I'm going to go int I, right? Oops. For int I equal, and over here what we'll call it is int I equal, we'll go data, I guess data start, right? That's starting at 0, so that'll start at the very beginning, right? If I'm thinking about thread 1. So that seems like a reasonable way to go. Why doesn't it like data? Oh, it doesn't like, I need the info, that's right. And data is just a void star. There we go. So that's kind of going to be where I start. Now I know that I want to go up until the end, so now it's probably going to be something like I less than info arrow end, right? So that's kind of going up until the end. If my end is 3, that means I go 0, 1, 2, right? So that'll give me kind of the first half of that array if I end up doing it with the 6 spaces that we had in the diagram, right? Something like that. So now let's go I++. Okay. So that loops through everything. Now I need to basically sum in those parts into this sum variable. So I'll go sum plus equal info arrow data, right? So now I'm going to the array inside of I, right? So I'm going to go to that I space inside of the data, right? And sum it up, okay? So this takes my sum on that particular part. And now, right, if I go over here, I can go info result equals sum, right? And so now my result is going to be saved back into that struct, right? I could have also maybe put some here, right? But just like I said, for demoing the struct, I'll put it over here. And I suppose I don't really need these if I only have one line in there, so maybe simplify it out. But yeah, that should be okay for us, right? So that function there, basically we just, pass it that packet of info, right? And it unpacks it and uses it to do its particular job of summing up that one half of it. Okay, so I think that looks okay. Let's actually try getting this to run. So the next step for us, right, is basically to create those threads, right? I'll start off with course with some boilerplate, right? So pthread tids, we'll do 2, something like that. Okay, so that'll be for my 2 different threads I need to create. So let's see, I'm just gonna copy paste these lines a little bit. I'm not gonna quite use them as is, but just to keep my head kind of focused on where we're going with this, we need to do a create and then we need to do a join. Okay. So those are my 2 TIDs. Okay, for each thread that I have, I'm going to need to create a struct, right? So I need to create a struct that's of the thread info type, right? So I'm going to go infos, and we'll just make that array of the same size, right? So I have 2 TIDs, and then 2 infos. Really quick, let's update our diagram. One potential thing that's going on here that is not quite good, but we'll put it for now, is that somehow, right, infos, right, those structs, right, so the struct right over here, right, has this data, right, this info struct, right, that's owned by P1, right, so P1, right, owns both infos and data. And the problem is infos right now is going to be one big piece of data, same as the data that we're going to analyze, and so that piece of data will get shuffled around our different CPU cores. It won't be very nice, right? So it's going to actually give us another point of slowdown, right? So as the independent thread, you're going to have to get both data and infos on your CPU cache to be able to do any work, right? So this is actually something that we want to maybe address in the future, right? So that's one big piece of data, right? And technically each of the threads is going to sort of have, a pointer to this, right? So the other argument here that we bring in over here. I don't really want to write data because there aren't written data over here, but technically, right, this is the argument that you get from pthread create, right? That argument is as a reference to info, right? So that's a little bit of overhead there potentially. So, but we'll go for it for now, and later on we'll look at it and maybe try to make things better. Okay, so I have those 2 info structs set up. Let me get my data entered in, right? So I'll do my data, and we'll just call it, like I said, we'll do like I said, we'll do 3, 3, 4, and then 2, 2, 2. So I should get basically 10 on one side, 2 on the other side. Something like that. And then I'll create a variable with a length really quick. Because we'll need it a few times. We'll do something like that. Okay, so I have my basic setup here. Now the next thing that I need to do is basically populate this struct over here. Now, for the purposes of this demo, I'm going to do it manually. You could maybe imagine also using a thread, using the loop to compute these values, right? For now, I'm going to write them out because I kind of want to talk through them. So as our first step, let's try basically just writing the code to do the very first thread, right? So that T1. So if I'm T1, right, and I go to infos, right, well, I'm going to be infos of 0, I know that I'm going to be starting at position 0. Kind of that's what we discussed, right? So we said that we're basically going to go from index 0 to index 2, and then because we're doing less than, we'll technically pass it a 3. So we'll start by assigning start to 0. Now we need to do end. End will be 3, okay? We're going to be 3, or maybe if we want to be more generic, it'll be length divided by 2, right? So I'm going to go halfway through it, okay? That length divided by 2 ends up being 3. All right, something like that. Okay, now what I need is to actually make sure that I'm passing it the right data. And I see I have a typo there. I'm going to basically give this struct a pointer to my outside data, right? So this arrow, this blue arrow, right? This blue arrow on either side, that's what I'm doing right now. I'm going to go infos of data equal data, right? Where now data is referring to this thing inside of the main. And I'll jump back up here and fix my typo really quick. Okay. So start and data. Don't need to do anything with result right now because it's going to compute the result, right? So nothing to do there. Okay. So now let's do our pthread create. Let's do this. Well, I'm going to just hard code this. Let's call this TID of 0. That's when we're starting to set up. And then we're going to not put any attributes, and then I'm going to basically point it at the thread function that I've created earlier. Okay. Now for my data over here that I'm going to pass it, I'm going to pass it infos of 0, right? So I'm going to give it this struct that's been set up, right? And so then when it gets to it, right, it can basically unpack it and get the different pieces that are inside of it, right? So something like this. Okay, so that should be it for my create. Let's do the join, because I want to run it basically on one side and hopefully, you know, it'll work for us. We'll do a join over here. We'll do a join on this first TID, right, the TID of 0. And then maybe we'll just print out the result, right? So we can actually see if we're getting what we want, right? And so this should hopefully give me, I think, 10 as a result. Yeah, 10 as a result. So let's try this over here. And we'll pass this. What do we do? Let's see. I want the result. It's going to be inside the struct, so it'll be infos of 0 dot result, something like that. Okay, that should be okay, right? So obviously we haven't done everything yet, but this should basically spawn a thread, give it those parameters. If that thread works, it'll sum up that portion of the array and return the result. So let's go ahead and run it and see what happens. It really is like a big thing for me when I click the button and it does what I want to do. That's a big thing. Okay. So now, right, basically, right, we have our first thread running, right? So now let's go ahead and set up the second one. Shouldn't be that complicated. We're gonna get to reuse some of our code. We'll do another result over here. So we'll print out the result from infos of 1. We'll do a join on 1 as well. And like I mentioned before, you can imagine this stuff all being in a loop if you want to make it more compact. For now, we're just writing it out long form. And then we need our other threads struct to be set up, and we need to create it with thread create as well, or spawn it. Both those words, you'll hear them in use. Okay, so this is going to be infos of 1 throughout here. And this is what's going to be a little bit different, right? So this is where you need to do a little bit of math, right? The other stuff will stay the same, but this is going to be different. Because it's the part 2 of it, we know that we're going to go from indices. Well, we're going to start at 3 and technically go to 6, right? We're just under 6, right? Because we did a less than. So the length in this case, the end in this case will be basically just length, right? So this will end up being a 6, right? And then we go less than over here, less than the end. And then for the start position, we want to start at 3. Basically, we're going to start at length over 2. Something like that. Okay. So that should be basically selecting that middle region of the data and printing it out, right? So we should be selecting this stuff over here and storing it into the other result. Let's give this a run and see if it cooperates with us. And it does. We get back a 6. So yeah, things are actually working pretty well. So let's just go over this program again really quick, right, and just summarize. So the problem here, right, is I have an array. I want to sum different parts of it in different threads, right? So I'm going to split it in half and do the work separately. This is actually sort of a balanced thing, right? I'm going to have 2 threads do the same amount of work. That way they complete at kind of the same amount of time, at kind of the same time. So I have this array here, split it in half, right? And the way we kind of handle that splitting is by saying, okay, there's going to be a struct where the struct knows about the data and it can kind of tell the thread, you start here, you end here. So you only do part of the work. And it also has a way to return out a result, right? And then our code over here is basically, let's populate that little package of information we used to give to each of the structs, right? Fill it out, spawn the threads, join them, and then print the results, right? And then over here, right, inside of our runner function, basically what we do is we kind of take the void, we convert it back to the type we want, and that means that then we can do the arrow thing on it to get the piece of data that we really, really want, right? And you can see us here going from the start to the end and summing up each part inside, and eventually, right, we get that sum, and we save that inside the struct as a final result that we print out later on. Okay, so this is kind of, I think, a pretty solid example of doing kind of computation in 2 different places at the same time. Under the hood, right, it's not optimal because of the memory allocation stuff, but in general, you see that we are using threads to do work and to potentially get a speed up. All right, that's all I got for you guys in this video. I will see you later on.